Well, hello there. In this video, we are going to take a look at object storage. What is object storage, you might ask? Well, object storage is a data storage architecture that manages and manipulates data as an object rather than blocks or files that are traditionally used in computer systems. It is particularly good suited for handling large amounts of unstructured or structured data such as images, videos, documents, backups, whatever you want. A question might come to your mind that why do you need object storage when you have file-based and block-based storages? Well, the answer lies in scalability and speed. Object storage is way faster than traditional methods, particularly when you have terabytes and petabytes of data. The simple storage cannot scale easily to such a large amounts of data. Now that we got that out of the way, let's focus on creating our own S3 backend server that we can use to store our personal data. By the end of this video, you will be able to create your own server, compartmentalize your data in various different buckets, and so much more. So without wasting any more time, let's get started. In order to get started, you need two things: a Linux-based server. I am using a VPS, but you can use any Linux machine at your home, and a client machine which will be used to interact with this backend server. I will do everything from scratch, so I will install Docker, all the required plugins, etc. But if you have Docker installed, you can skip ahead. The first thing we will do is update our system. I'm using Debian 12, but it should work on most Debian based systems. Type sudo apt-get update to update your repos. Next, we will need a tool to download the Docker install script. We will use curl, so just type apt-get install curl and this will install curl on your system. If you want to check or verify it, you can type curl version and you should get a similar output. Next, we will download the install script from Docker. This makes it super easy to install Docker on your machine without doing each step individually. Simply download the script and it will install Docker plus all the plugins that you need, which include Docker Compose, which we will use later in this video. Next, we will add our user to the Docker group so we don't have to type sudo each time we want to do some operation with Docker. Let's also see if Docker Compose is installed properly, since we will use it to create Docker Compose files for each service that we will use in this video. Type Docker Compose version and it should display some output with the version number. Now, since we are hosting our S3 server on a VPS, we will need to set up some things first. We will use a reverse proxy to have a secure access because we don't want our data to be accessible without any encryption. So let's first install caddy. For that, we will create a folder. Let's call it caddy proxy. And inside this, we will create a Docker Compose file. For Docker to communicate with other containers, we will create a Docker network which will only be used by a reverse proxy. So let's create the Docker network with Docker network create and then the name of the network, which in this case is caddy network. This will allow caddy and the S3 backend server to be able to communicate with each other. Now let's create the compose files for Docker. First, we will set up the network field and set the Docker network to the caddy network that we created earlier. We will use the Alpine image for caddy to ensure a small disk footprint. We will name this container as service caddy to be able to easily identify which container we are talking about. Now, caddy uses two main ports for port redirection. So it's port 80, which is used for HTTP, and port 443, which is used for HTTPS. This will allow us to have secure encrypted communication between us and our server. Next, we want to map volume so that data is persistent even when the container is restarted, etc. A Docker socket is mapped so that the container is able to interact with other containers. This step is optional, but it's a good practice. Now we will use a caddy file where our reverse proxy settings will be stored, but we will come back to it later. And now we set the restart policy to unless stopped, so that it means unless we manually stop it, the container will continue to run. Now let's create a MinIo folder and its own Docker Compose file. We will keep these two separate so they don't intermix with each other. As we did in the caddies case, we will use the same network image. We will use the official image from MinIO, and let's name the container as service MinIO. Next, you have to decide the username and password. So I'm going to use some random password and the user will be called test user just for simplification. The network will be caddy as before. Next, we want to specify the command that will run the dashboard because we want to see what the backend server is doing, etc. So MinIO basically uses two ports. Port 9000, which is used by the actual S3 server, and port 9001, which is used by the dashboard to see what is happening with this server. If you want to run this on your local network, you don't need domains, but since I'm running this on a VPS server, I will use two domains to be able to interact with it. One s3.homelabchronicles, which is my domain, and the other one will be s3 dashboard, which will be used for you guessed it, dashboard. Now we will create the caddy file that we talked about earlier. In this one, we will set up the reverse proxy forwarding rules. So port 9000 and port 9001 will be linked to the domains and the appropriate ports on the container. Now everything is ready, but before I proceed, I will create two small scripts. And these scripts will be used for starting and stopping the Docker services. I don't want to type Docker compose each time I want to start. Now the caddy or the reverse proxy part is complete. Now let's start caddy. It will take some time to download, but once it's done, you can type Docker PS to verify if caddy is running properly or not. Now simply go to the MinIO folder and run the start script. This will pull all the Docker images and it should start up the S3 server. Now to access the dashboard, you can go to s3 dashboard dot whatever your domain name is, and you can use the password that you set in the compose file to access the dashboard. So once you are logged in, you need to create a bucket. Now bucket is something that is a fundamental for object storage mechanism. Every data is associated with a certain bucket. Let's create a test bucket, give it some name, let's call it test bucket. You can do a lot of things with S3. So for example, you can do versioning, which allows you to create basically different versions of the same file. So if you have a file and you update it later, you can access both versions of the file. There are other options like object locking, which makes this data read only, so you cannot delete it. You can also exclude some folders if you want. And now if you go to the object browser, you can see your newly created bucket. The current bucket is empty, so let's put some data into it. MinIO supports drag and drop operations and also upload feature. So let's take this image and drag it to the dashboard, and it will save this image in our bucket. That's it, your storage is now working. Now the important thing about MinIO is that it does not modify the contents of your file. So for example, if you want to access the files through the file system, you can go on your server and go inside the data folder and you will see all your data in different named buckets. This is essential for easy backups. If you want some third-party application to be able to interact with your S3 object server, you need to create access keys. These keys are a pair of public and private keys, and these keys can be used to communicate. Remember to save your private key because if you lose it, you lose your data. And with this, we come to the end of our video. I hope you liked this video. Don't forget to like and subscribe, and see you in the next video.